All right, guys. So if you remember before spring break, we were in the middle of our data kind of analysis unit. So we were going through a lot of different representations and graphs you can have and kind of when you use them, when they're good, when they're bad, how to read them and how to make them ourselves. And the last one that we were going to go over was line graphs. So what I decided for our first week of virtual teaching was to go over line graphs, and then you guys are going to do a small project with line graphs the next day this week. This is workshop, so that's going to be on Friday. Yes. Okay, so this is called the Essentials of Line Graphs. If you do want to take notes to help you on your project, you're welcome to. Otherwise, you will be able to refer back to this lesson later in the week. And honestly, a lot of this stuff is what we've done with Graph of the Week throughout the year, so it should be mainly review. So today's plan, just as I said, watch this video. It will help you prepare for the project we're doing later this week. And then after that, you really don't have anything else. Just have a nice afternoon. So the objective, it says objectives, but I guess it's really just one. I can interpret a line graph and answer questions about its basic features. So we want to identify multiple things about a line graph and then also just answer questions about it. So first off, we're just going to start with the definition. What is a line graph? Okay, so it's very important we know like what it is, how to identify it, and then we'll see how we can use it in mathematics. So what is a line graph? It is a graph that shows information that is connected in some way. And line graphs are usually used or often used to show change over time. So if you are looking at a graph that is showing how some variable is changing over time, and a lot of times if the x-axis, if the x-axis is time or years or something like that, then you're probably looking at a line graph. Next up, pros and cons. So the pros of a line graph. A line graph is really good at showing the relationship between two variables. And it is also a good visual representation of trends and changes. Okay, so you're always going to have like an input and an output with a line graph. Sometimes you can even have multiple variables, so not just even two variables, but 3 variables or 4 variables being compared. And then again, you can really see visually what's going on with a line graph. So if the line's going up, you know that'll tell you about a trend with the data. There are, however, some cons with line graphs. Okay, line graphs can quickly get cluttered. And that makes them hard to read. This is especially if you have multiple lines going on the same axes. And then oftentimes line graphs have bad scales on them, and they can be misleading. So oftentimes you'll see line graphs like on the news or on social media or something, and it wants you to think one thing because they made the scales bad or because they formatted it in a weird way. And so line graphs can be misleading in that way, so you do have to be careful. So that is what a line graph is. That is the pros and cons of a line graph. Now what we're going to do is we're going to take a look at one and see if we can practice identifying those features. So here's a line graph. This graph shows the growth of manufacturing in the first half of the 19th century. Okay, this is for the United States. And just as we do with Graph of the Week, you can look and find a source. So the source is Historical Statistics of the United States from 1789 to 1945. So the first thing that I want you to find is the title. And again, we've practiced this with Graph of the Week, so you can probably find the title. The title is usually located above the graph in a bigger font. So it is going to be National Income from Manufacturing. Oh, almost out of room. The x-axis is what goes along the bottom of the graph. Okay, you do want to be specific. So let's see, we have different years. And then notice too, kind of a more specific question, what is the scale? So the scale is what are the increments, or how big are the gaps between all of the years along the bottom? So the way I figure that out is I say, okay, I'm going from 1799 to 1809, 1809 to 1819. What is the difference between all of those numbers? And a lot of you are going to be able to do that in your head. This goes by 10 years. So every time I have a new unit on my graph, every time I have a new line on my graph, it has been 10 full years. The other thing you could say is decades. Okay, the scale on this is a decade. The y-axis is going to be the axis that goes up and down. So it's this one up here. And you can see there is a label for that one, which makes it nice. So it says millions of dollars. And then again, I want to know what the scale is. So I look at the different labels and I say, how much is each number going up every time they label it? So 50, 100, 150, 200, 250. So the scale is $50 million. Okay, keep in mind, it's not just 50, not just $50, it's $50 million. So that is a really big difference. And then lastly, what does the line represent? So what does the black line represent as it goes through and shows us change on this graph? That is going to be basically what the title tells us, the national income from manufacturing. Okay, so we can just write income from manufacturing. Can I make it? Oh, barely. There we go. So far we've practiced finding the title, the x-axis, the y-axis, and then what the line represents. After this, we're going to be looking at the same graph. However, I'm going to ask you questions about it. So think to yourself, and again, if you want to pause the video, you're welcome to. What was the national income from manufacturing in 1829? One thing you want to think about is, am I given the year or am I given the income in dollars? And in this example, I am given the year, 1829. So I want to know what amount of millions of dollars corresponds with 1829. If I go along the x-axis to the year 1829, you can then go along that line to find where that's going to be on the line graph. And then you can sort of follow that point. You can either draw this in or you can follow it with your eyes to see how many millions of dollars that is. So in 1829, the national income from manufacturing was $100 million. Lots of money. However, I could also ask you, in what year did the income hit $200 million? In that example, I'm not giving you the year, I'm asking for the year. I am giving you the amount of income that there was. So you're going to want to look along the y-axis for millions of dollars, and you want to look for 200, And then you're going to kind of go the opposite direction. So you're going to say, okay, I want to find where the line was at 200 and then approximately what year that was. So we're basically locating two ordered pairs or two data points on this graph. I can see that it is somewhere between 1839 and 1849. It's a little bit closer to 1839. So let's see, if that was 5 years, I'd maybe say 1842. And that is an estimate, which is okay. Obviously, if we had this on a computer or if we had a smaller scale or we had every single year printed on there, we'd be able to get a better estimate. But I think 1842 is a pretty good estimate. And then what section of the line graph has the largest slope? So this is actually probably the hardest question. All I'm asking is for you to connect what we did with our slope chapter to what we are doing with line graphs. And also think, what does it mean to have a large slope? Well, if you're comparing slopes and you have one that is larger than the other, the way that that is going to look on a graph is it is going to be steeper. Okay, so if I have a slope like this and a slope like this, the one that is steeper is going to be a larger number or a larger fraction for slope. So what I want to do is I want to look at each section of the graph, look at their slopes, and say to myself, which of these slopes is the steepest? It says which section of the line graph has the largest slope, so you can give me a range of the years for the slope that is the steepest. So go ahead, think in your head which section has the steepest slope, which section has the largest slope. And then see, did you put 1839 to 1849? Visually, we can tell because that's where, in other words, like the hill gets the steepest. If this was a hill, you would really not like walking up the last section of it. So that is where the slope is going to be largest, between 1839 and 1849. And in the context of the problem, that means that manufacturing had a boom in the 1830s and 1840s. So maybe you can go bug Miss Orlick or one of your social studies teachers to figure out what was going on in the 1830s and 40s that created such a boom. I believe it was an entire revolution that was going on in the industries. Last but not least for today's lesson, we do have a family fun challenge. So pick someone at your house and add a picture or video of you explaining the following math problem to them. Share it in the comment section below. I will post the correct answers later this week. So I have given you another line graph, and it says identify all of the following for the line graph below: the title, the x-axis, the y-axis, scales if you can, bonus, and 2 observations about the line graph. So find somebody that is social distancing near you and explain this problem to them, and then send me a picture of you working on it. So pause the video, work on that. Hopefully you figured that out with somebody that is social distancing with you. And last but not least, think to yourself, can I do this objective? The objective for today's lesson: I can interpret a line graph and answer questions about its basic features. Do you feel like that's something you can do on your own? Do you feel like that's something that you can do confidently? And if the answer is no to either of those questions, what are some things you can do that would help you be more confident with that knowledge? So if you want to reach out to me via email or via the YouTube Live or via the questions sheet or any of those places you can reach me, go for it if you are not feeling confident, and I'm happy to provide you with more resources. Thank you for watching. That is all you had to do for today, and then you will have a small project later this week. See ya!